Now let's look at the Pythagorean identities. We're going to use our first Pythagorean identity, the sine squared theta, which I did write in this notation, plus cosine squared theta equals 1. Remember, I've written that as sine theta squared plus cosine theta squared equals 1, to derive two more similar identities. So to obtain the second identity, I'm going to divide both sides of this original identity by cosine squared theta. If I do that, notice I have sine squared theta plus cosine squared theta all over cosine squared theta equals 1 over cosine squared theta, which now if I take the left side and break it into two fractions, I end up with sine squared theta divided by cosine squared theta plus cosine squared theta divided by cosine squared theta equals 1 over cosine squared theta. And so just notice when I go to do this, if I do a little simplifying, I notice first of all cos squared theta over cos squared theta is 1. And then notice I rewrote the sine squared theta divided by cosine squared theta as sine theta divided by cosine theta all squared, which is legitimate to do. And similarly, I took the 1 over cos squared theta and I wrote it as 1 over cosine all squared. And when I do that, I notice that sine over cosine, sine theta over cosine theta is tangent, and so I end up getting tangent theta squared, tangent of theta all squared, plus 1. And remember, 1 over cosine theta is secant, so that's going to give me equals secant theta squared, or secant theta all squared. This last line is the second identity. So if I take the tangent of theta and square it and add 1, that should give me the secant of theta. Similarly, I can get the third identity. Instead of dividing by cos squared like I did in the previous example, I'm going to divide by sine squared. So I have sine squared theta plus cosine squared theta over sine squared theta equals 1 divided by sine squared theta. So there's my division. And if I simplify, remember I'm going to break it up into two fractions. So sine squared theta divided by sine squared theta plus cos squared theta divided by sine squared theta equals, and then I have the 1 over sine squared theta. Once again, the sine squared theta divided by sine squared theta is 1, so we have that same type of process. And then I pulled out the square, so I have cos theta divided by sine theta all squared, and I have 1 over sine theta all squared. Cos theta divided by sine theta is cotangent, 1 over sine theta is cosecant, and so I end up with 1 plus cotangent theta all squared equals cosecant theta squared. So these two identities you need to either remember or derive. I will tell you that yes, I've been teaching this long enough that I remember them, but I do technically remember them by doing that quick derivation in my head just to make sure that I have them set correctly. So you'll want to make sure that they are something that you do recall or that you can quickly derive.